Okay, in this video we're going to look at measures of spread. We're going to use it to answer the question, which gender has a more consistent level of sugar reduction? So as well as looking at which gender has a higher average, it's also important to look at how consistent a gender is. Now, if one gender has a larger variation of sugar reduction as a result of sugar-free Feb, then we can't be as confident that sugar-free Feb will be successful for them. On the other hand, if another gender has a smaller variation of sugar reduction, that is to say more consistent sugar reduction, then we can be more confident of the effect that sugar-free Feb will have on them. There are various ways that we can measure spread or dispersion. The simplest is the range, and that is the difference between the maximum sugar reduction and the minimum. We can use the range formula for this, although if we want to look at particular subgroups, we're presented with a similar problem that we had with the median. We need to build quite a complex formula, or have different subgroups, different tables for each group we want to look at. Now, a nice workaround for this is to use the pivot table to show us the maximum and the minimum values, and then we can subtract one from the other. So let's have a look at how we could do this here. If we clear it, if we pop sugar reduction in the values and we change that to summarize them as the maximum, so that is the most anybody reduced their sugar intake by. If we drop sugar reduction in there again, we can now change the second one to show us the minimum, which was minus 96, so somebody actually increased their sugar intake. Now, if we want to then show that by gender, we can drop gender in there, and we can then copy and paste these values into a new sheet. Let's call that spread. Paste our values in here, and then we can do a simple equals 1, take away the other. And there we have our range. So we can see that the range of sugar reductions for for females is bigger than the range of sugar reduction for males. Now, first off, that might lead us to think that males are more consistent in their sugar reduction than females. Females are more varied and more spread. However, the range is quite limited in its usefulness because it will be completely thrown by a single extreme value. If we have one particularly high value amongst the females or a particularly low value, that's going to make the range massive. For that reason, a much more useful measure of spreads is the interquartile range. Now, we mentioned this a little bit earlier. Rather than looking at the difference between the highest and the lowest value, like the range does, the interquartile range chops off the top 25% of values and the bottom 25% of values, leaving us with just the middle 50%, that middle box in a box plot. And then it takes the difference between the highest and lowest values of this middle group, this kind of core set. And this gives us a much more robust measure of spread because it's not looking at the extreme values at either end. Again, it's quite tricky to do the interquartile range in Excel. We can use a quartile formula to calculate the boundary for the upper 25%, called the upper quartile, or for the lower quartile, the boundary for the bottom 25%, and then we can subtract one from the other. But to do this for different groups, we need to do the calculation multiple times. The easiest way to see the IQR, the interquartile range, really is by constructing a set of box plots for each group we want to look at and viewing them alongside each other. Remember, the box in a box plot shows us the middle 50%. So if we head back to Plotly, plot.ly, and we want to take our sugar reduction data. So if we copy that column, notice that these numbers here are blue. That means I've still got a filter applied. That was from when we looked at different age groups earlier. Now, if I just copy this, it's only going to copy it with the filter that I've applied, and I want everything. So if we just go to data, I can clear that filter and we can copy it again. Do always look out for that because that can lead to some pretty big errors. Okay, if we head to Plotly, we want to create a chart. It's done this again. Just press F5 to refresh, and that should sort it. I don't know why it does that. Now we're going to choose a box plot when we're given the option, and we're going to paste those sugar reduction values in here, and it's going to generate a box plot for us instantly. Okay, if I turn that into box plot, paste the values in there, tell it that the values are in column A, and there's our box plot. Now, if we want to look at that then for different groups, we go back to our data, and if we also copy the gender column and paste that alongside Control and Home to go to the top, paste that alongside the sugar reduction data, we can ask Plotly to split our box plot by gender. We scroll down, we can see there, that's instantly showing us that big female range that we had before, much bigger than the male range. But we can look at the interquartile range, the size of this box, the difference between the upper quartile and the lower quartile. And actually, it's really quite similar for males and females. And so whilst clearly the range is bigger for females, the interquartile range is similar. That suggests that actually they are similarly spread once we ignore these extreme values. The next method of spread we're going to look at is the standard deviation. Now, the standard deviation of a set of numbers tells us how close the numbers are to the mean. If the standard deviation is a big number, it means the values tend to be further away from the mean. If the standard deviation is a small number, it means the numbers are tightly clustered around the mean. So bigger number is more spread, less consistent. Now in your exam, you'll need to be able to calculate the standard deviation using your calculator and some formulae. But in this video, we're going to focus on calculating this quickly in Excel and then interpreting it. Let's go back to our pivot table and clear it. And then we're going to drop sugar reduction into the values box. Now we can actually right click on here, summarize values by, and we can change this to standard deviation. Now lower down the list, it's got STD dev, that means standard dev. Click OK. Instantly we get the standard deviation of sugar reduction for our entire data set. Now this is meaningless unless we're actually comparing two groups. So if we drop gender into the rows box, we can split that standard deviation by gender, just turn that into something a bit nicer to look at. Now, actually, according to the standard deviation, males have a slightly greater spread than females, but actually the numbers are pretty close together in the grand scheme of things, 381 versus 399. And so putting that information together with the box plot we looked at with the similar interquartile ranges, I'm actually going to conclude that there's no difference in spread here between the two genders. Now, the standard deviation is probably the most commonly used measure of spread because whilst it doesn't completely ignore outliers like the interquartile range does, it's also not completely thrown by the outliers like the ranges. And so as long as the extreme values aren't too extreme, it's probably the best way of measuring spread. Now, in addition to the quartiles, which split the data into 4 chunks of 500 in this case, we can also calculate percentiles. Now, percentiles break the data into 100 chunks, so that would be 100 chunks of 20 people each. Now, whilst the interquartile range chops off the top quarter and the bottom quarter, the top 25% and the bottom 25%, we could calculate an inter-percentile range, maybe between the 10th percentile and the 90th percentile, that would just chop off the bottom 10% and the top 10%. And we're going to quickly look in Excel about how this could be done. So if we go back to our spread, let's write in the 90th percentile and the 10th percentile. So we're going to calculate this for the entire data set. We do equals percentile, open brackets. We want to do it for the sugar reduction data, comma. And this number here, that tells us which percentile we'd like, and it requires it to be a decimal from 0 to 1. So for the 90th, we want 0.9, enter. And actually, we can just copy that and tweak it for the 10th percentile. If we change that 0.9 to a 0.1, there we have it. We've got the 90th percentile, the 10th percentile, and we can calculate the 90th or the 10th to the 90th into percentile range there. So that is the difference between the highest and lowest values if we're just focusing on the middle 80% of our data. So just skimming off those extreme values at the top and the bottom. Okay, have a go at this exercise here, check your answers, then move on to the next video.